Welcome back. In this video we're going to look at vectors, and in this section we're actually going to jump out of the textbook for a little bit and look at both vectors and angles. And angles, we're going to rely on some of your knowledge from geometry from your previous schooling. But at the end of this, what we want to be able to do is look at movement on the Cartesian coordinate system using a vector, and then to do that we're going to kind of look at algebraic and geometric properties and talk about the length of a vector, or the magnitude, and then also talk about direction. And then here are a couple resources that are pretty good on vectors that you might find useful. So enrichmaths.org, and then that, or mathopenreference.com/angles, and this will just give you a bit of a review. Now this next question, we have seen this before. We're going to talk about distance and displacement a little bit in this video, so we have this scenario where Jody is traveling from home, and we saw this question earlier, but then we talked about it in the context of a distance formula, and so, well, that's okay, that's fine, but maybe there's another way to think about this. And if you want, you can open up these slides to the calendar and access this link, or just type it in and play it. It's kind of fun. It's kind of like Minesweeper, but you get to see where all the mines are. But the idea is you're going from one target to another, and so you want to know how many moves you can make, or some challenges you might want to try. How many moves are you making? What are the fewest numbers? How far do you have to move? And how are you moving? So go ahead and play that a little bit at your own time, or on your own time. But when I played it, here was a game that I played, and I'm just wondering, what questions could I, and I'm a mathematician, what can I ask about this game, or ask from this game? And I'll just give you a moment here to think about those questions that you could ask. Well, as you were thinking, the likely question that you came up with was, how far did you travel? And so the path that I traveled is illustrated in blue, so I moved from the blue target in the upper right to the red target in the lower left, where my little creature is. And so I couldn't have gone straight because of the mines, right? So what would the straight line distance, what would that look like? Well, that would just be extending from here to there, and we're gonna, that's actually mostly a straight line, so if not, pretend it is. But if I did that right, I ended up hitting the mine right over here, so that's not great. But if I were to find that distance, remember, that's just the distance formula, which we saw previously, okay? So we could compute the distance that I traveled on that red straight line. But I didn't travel as fast, so what would I do? Well, I would have to, again, kind of find this point here, which happens to be nice, that's well defined, so let's just label it. So this is 7, 4. This point down here is 2 minus 7, and then here I'm at, oops, let's go back. Let's see, I'm at minus 6, comma, minus 8. Okay, so then what I could do is, do the distance, and let's call this D1. I can find the distance for this first segment, extending from there to there, and then I can find D2, which extends from there to there, and add those up. Okay, great. Old news, right? If I end up doing that, what I end up getting is, if I do that straight line distance, again, that would be the length of this line. That one isn't as great, but imagine it's a straight line. Straight line distance ends up being square root of 313, and if you do that in calculator, you get 17.69. And the entire route, so this D1 that I was mentioning before, and D2, if you add those distances up, it's 20.15. And so the question is, great, we have two distances, right? So which one do you report? Okay. Now, in reality, when we're talking about physical quantities, both of these calculations are valid, but they represent different quantities. The straight line distance, or the red line that we computed, or that is shown here, is called displacement. Okay? And so the idea with displacement is that it's how much ground has been covered, or how far out of place an object is. And so really, to compute that, all you do is compare where you started to where you ended. And we'll go through this in section 3B, when we actually get to physical concepts, but I just want to make you aware of this. But the reason we're talking about this here is that displacement is a vector quantity, meaning it requires a number, which we call a magnitude, and a direction to fully describe. Okay, so we need to say, oh, we're heading, 5 miles north. Perfect example of a vector quantity. By comparison, the entire route that we went, or the d1 plus d2, that's the distance, and sometimes we might make a further distinction and call that total distance traveled. And this is not a vector quantity because, again, you would just say, like, if you're thinking in your car, and how far your car travels in a day, it would be, I traveled 50 miles in a day, right? But you're starting in the day in your garage, right? And so when we talk about distance traveled, that's just a scalar quantity, and all we do is communicate a magnitude with it. Okay? And to help you delineate these two ideas, we're going to watch a short YouTube clip here. But before then, I have a quiz question that I want you to just make sure that you're understanding these concepts correctly. Of the two distances that we see here, which one is going to be our displacement? So I want you to answer that in the next quiz question. Okay, and here's the YouTube clip that we are going to end the video with.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh, ah! Gosh, it's so difficult sometimes to get the brain back inside of me.
Anyway, remember, vector has both direction and magnitude.